Thank you very much. Really appreciate it. Thanks very much for having me. So, as I said, the session is going to be here about, we're going to talk about an introduction to Terraform, which is a technology for managing resources for deployment on cloud. My name is John Martin. I'm a data platform MVP, chartered IT professional. My pronouns are he and him. So my contact details there are on SQL Diplomat on Twitter, and my LinkedIn's there as well if you want to get in touch after the session. So obviously for a great cause, appreciate any and all donations in support of the organization. It's a great conference, some great speakers and some fantastic content here, and anything that people give is much appreciated. Big thank you to the sponsors, obviously, who helped put this on for us. Feedback, so speaker feedback, really important. If you've got anything for me, so some suggestions of how I can improve or things I'm doing well, please let me know. And obviously event feedback is fantastic. The organizers really looking forward to that so that they can make sure that they put on the great events again. So before we dive in and look at Terraform and understand exactly what Terraform is, we need to understand the concept of infrastructure as code. And this is something that's really sort of come to the fore in the last couple of years. And as we've moved from a traditional operational infrastructure on premises, that type of thing, and we started branching out, we started using either sort of cloud first technologies, or we're starting to use sort of hybrid scenarios. But even then, filtering back to on premises with the advancements that you'll see in things like VMware, Hyper-V, and other platforms that you can deploy using code, taking everything from either running it manually, like we used to do, so we'd run an installer, or we'd manually go through UIs and what have you to deploy resources. Then we move on to sort of some scripting sort of tasks, so a bit of PowerShell here and there, that type of thing. And we would have scripts that may be quite complex, that maybe we would have to pull everything down and remove things before we could redeploy those scripts, things like that. Moving over to an infrastructure as code mindset means that we're adopting some of the development techniques that exist from, say, .NET, Java development, that type of thing, which if we bring those into the way that we manage infrastructure, so we're deploying servers or cloud resources or anything like that, it gives us a little bit more versatility. And one of the key things that this gives us is traceability. Okay, there is always going to be a case of who made what change, where, and when. I know that when I'm troubleshooting infrastructure myself, trying to understand, okay, well, what's changed, because that's one of the things that might clue me in on exactly why I may be seeing a particular issue or particular behavior, that type of thing there. Now, traceability, obviously, if we're committing everything as code, we're putting it into source control. When I make a change, I commit that, I put a comment in it, then people know that I made a change to the way that something may be defined, why I made that change, what it's linked to, maybe issues, that type of thing. And we end up with that history. That makes life a lot easier for people who are coming in. Now, that also means that we can line it up with our infrastructure, with our application code, for example. Okay, so by again leveraging that source control capabilities, we end up with a lot more documentation. I don't like the term self-documenting, but at the same time, it gives us that documentation that's there for us to use and maybe put into another form. The other thing as well about infrastructure code, it allows us to sort of take encapsulation and really bring that through to simplify our deployment scripts, to understand how we're going to manage our infrastructure. So back when I started using Hyper-V and VMware and things like that, I could end up writing very, very long PowerShell scripts, either for Power CLI or for native PowerShell to use with the Hyper-V clusters, System Center, Virtual Machine Manager, things like that. And trying to write them in such a way that I can mask a lot of that complexity from some of my colleagues who may not necessarily have all of the experience for running these things or fully understand the code. I basically want to be able to say, right, we've developed this piece of code which will deploy this infrastructure in a specific way. And all you need to do is feed it the variables, feed it the values that it needs, system names, IP addresses, firewall rules, things like that. If we can encapsulate all of that complexity and move it to the background, it allows people to focus on delivering results, delivering value. I want to deploy servers. It becomes something very, very quick and easy to do. Is I take that piece of code off the shelf, I put in some parameter values, and out comes some system. Okay, so again, by doing that and masking and removing that complexity, it makes for a lot easier sort of pathway. It also means that we can start looking at automating more effectively as well. Versioning. I mentioned when I spoke about traceability that you've obviously got the source code where you've got the commits and you've got the and the messages and everything with that goes with that. The other thing we can look at is really sort of linking about our infrastructure as code as versions. So if you think of version 1 of your infrastructure, for example, now we're deploying a brand new platform. We've got our application developers who've developed some code, or we've bought our applications off the shelf. And this is what our infrastructure needs to look like in order to deploy it effectively. That's version 1. 6 months, 9 months down the line, we've got a new release, we've got a patch upgrade, things like that. We want to make some potential changes to our infrastructure. That's 1.1, 1.2. Potentially, if it's a radical change, version 2 of our infrastructure. And then you've got the corresponding version of the application. So you know that version 3 of your application runs on version 2 of your infrastructure, for example. So you've got that linkage, so you can understand what the components are that go into all of it as well. And it means it's repeatable. That's the key thing as well. It means that I can deploy that same chunk of infrastructure repeatedly for those applications, whether it's in development, whether it's in test, whether it's in production, whether I'm using a multi-tenant system where I've got many customers and I want to stand up in exactly the same piece of infrastructure for the application for that particular customer, things like that. So I can take that and I've got a lot more control over it. And then there's the idempotence. Now, this again comes down to historically the scripts we'd have to write were, okay, I want to deploy some resources. That's not too bad. But if I want to be able to rerun that script over and over and over and not have it cause any damage or overwrite values or things like that, I then have to add a lot more complexity to my code. And essentially, I want to go in, I want to double check, okay, is the value set to the current value? If so, right, leave it, move on. If it's not set to the current value, okay, do I need to update it? Can I update it? Do I have to destroy the resource? And then do I have to deploy a new one? Or what are the interdependencies? All that sort of stuff there. Whereas if I can write my code in such a way that it's idempotent, I can rerun it over and over and over, and it's not going to make, I can get the same thing out every single time. So that becomes very important. Now, if we're doing all of this manually, it can be very, very complex. Like I say, when you build your own PowerShell modules, you can build your own libraries of code that will do a lot of this. But then there's a lot of stuff that comes off the shelves. The tools that are available to us in the cloud world right now, the things that some of the vendors are bringing out, makes our lives a lot easier. Okay, so we start thinking about why we want to do this. We take that approach of infrastructure as code, and what it means is we can end up with a greater level of consistency. Now, I've been in the industry long enough to remember when we were building things by hand a lot of the time. We'd give something to the junior DBA, and as part of their learning cycle, they would be going and deploying new servers, and then have a build sheet, and then they'd have the installer, and they'd have various other things. They'd be setting everything manually. And even with those build lists, you'd end up with something coming out the other end that may not necessarily look exactly the same as what came before it, what comes after it. So by moving to an infrastructure as code perspective, it gives us that increased consistency. It reduces the chance of error. People are fallible. That's how I've learned over the years. I've made mistakes. And if we can remove that from our infrastructure deployments and the way that we're managing things, that makes our lives a lot easier, and we can concentrate again on delivering value. That's the key thing here. By removing and eliminating this complexity, we're not taking anything away from the people. We're just letting them actually spend more time on delivering true value to the businesses and our customers that we're running these systems for. That repeatability as well. So consistency leads on to repeatability, which means I can repeatably deploy the same configurations for production and then feed it back into test. I can feed it back into development. So if I need to make changes, I don't necessarily have to have an environment there all of the time. So when you start thinking about on-premises, yeah, you may provision large VMware farms or Hyper-V farms or what have you. And then we'll have them sat there. Sometimes they're working, sometimes they won't. We may spin up an environment. It's got 20 different servers in it. Now, there'll be a reluctance to tear that down because to deploy 20 servers might take some time. But again, moving to infrastructure as code, we're confident we can consistently and repeatedly redeploy that environment. Then we can look at saving resources. Now, you take that to the cloud. What that means is you're going to spend less money as well. So you go to Microsoft Azure, you go to Amazon, AWS, you go to Google Cloud Platform. If you've not got resources deployed and running, you're not going to be spending money on them. So again, by moving that, you've got some real tangible benefits to the businesses that we work for by saying, well, if we adopt this approach, we can actually save some money on the bottom line by how much we're spending on these resources. And we can be more reactive. So if I need 5 environments, I can spin them up very quickly in a day, as opposed to taking several days to do them potentially. And that leads on to the automation piece. When we've got everything written down as code in that sort of way, we can easily then plumb it into the likes of Jenkins, Azure DevOps, Bamboo, any of these build systems. We can then start leveraging things like Ansible, Chef, Puppet, all of these platforms which will help us coordinate the execution of our code to spit out an infrastructure that looks how we want it. And when you start thinking about lining that up and bringing in the application deployment pipelines and everything like that as well, you can build automated testing systems very, very quickly and easily. So it will deploy the infrastructure as you're expecting it to. That can get tested. Then it will deploy the applications. Again, you'll get all of the tests running through there if you've got the test automation in place as well. And then you get all the reports out the end. So you can be confident if you make a change to your infrastructure, you essentially say, what if? So if I take that version of my application and deploy it on this new version of my infrastructure, does it come out the other end and look the right thing? Do I get the right results? Do all the tests pass? So again, when you start thinking about wanting to be able to do things more reliably, by putting it into this sort of scenario, it means that if you're in any industry that maybe has some regulatory compliance around how you coordinate change, or if you've got change advisory boards and change control in place, by getting everything lined up and scripted in such a way, it means that you can be confident when you raise that change. You can say, well, here's the test sheet from all the work we've done to say, look, it works fine. So now we can move forward and deploy to production. So this session is about Terraform, but what other options exist at the moment as well for us? Well, this is where it depends on which platform you're using. So if you're using Microsoft's Azure platform, then obviously you've got Azure Resource Manager. So that's a sort of JSON-esque type scenario where you can build out and define your resources and your infrastructure and then deploy that to Azure. If you're on AWS, then you've got Cloud Formation, Google Cloud Deployment Manager. And then there's good old PowerShell as well if you want to wrap it up and do things yourself that way. So if you're doing some on-premises deployments to say VMware, you've got PowerShell, you can use that PowerShell for Azure as well. So there's a lot of different things that you can do. Now, that's great if you're in a business where you're only using one particular cloud vendor that might or technology vendor, then what that gives you is you don't have to look at that full range of things. But if you're working in the industry, you're a consultant, you're a contractor, you work for an MSP or something like that, you potentially deal with multiple platforms, multiple technology platforms. At which point, having to learn and try and remember, okay, well, do I use Bash for this? Do I use PowerShell for that? Do I use ARM? Do I use Cloud Formation? It can get a little bit more complex and a little bit overwhelming. And again, it sort of introduces inefficiencies into the way we operate. And this is where Terraform really comes into its own, because Terraform is a consistent way of doing things through a single interface. And what that means is that I can define my infrastructure in a consistent syntax. So for Microsoft Azure, for AWS, for Google, VMware, I can use the same syntax constructs to define my infrastructure. The exact parameters and values and the way that we do that around defining resources will be different on every platform, because what Terraform does is it actually interacts with the APIs. Okay, so you've got a provider for the various different technologies in place. We'll discuss what providers are in a little while. But what it means is that everything's got a similar structure, similar sort of language that they're writing the definitions in. But for example, a virtual machine definition for Microsoft Azure will not be the same as a virtual machine image definition for AWS. But the structure and the language and the concepts that we use to define those resources will be the same. So it dramatically reduces that sort of need to learn multiple platforms in a lot of depth when it comes to the code you use to deploy things, as opposed to just having one cloud agnostic deployment system. That's not what this is for. This is more about giving you an interface to be able to work with all of these other technologies. So what exactly is Terraform? How does it hang together? How do we actually make use of this? Okay, the first thing to understand is Terraform is a multi-platform command line tool more than anything else. Okay, so it runs on Linux, Unix, Mac OS, Windows. just a little executable, little binary that you drop in, and you can start calling. So when you drop it into your, I'm going to show you later, I'll run it here in Windows, and I'm using VS Code as my interface for running everything. Just stick the path to the executable in the path variable, and then I can call Terraform from the command line to do whatever I need to do. What that also means is that it's really useful for plugging in, like I said, to Azure DevOps, to Jenkins, to Bamboo, and things like that as part of a deployment pipeline. Again, it's just a command line tool, so if you put it on your build servers, things like that, you can call it as you need to. The language used as the syntax is Hashicorp configuration language. So Hashicorp is the company that produces Terraform. One thing to note is that Terraform itself is free. There are some additional capabilities that Hashicorp have around it, which is paid for offerings, but everything that I'm going to show you today can be done so long as you've got an Azure and AWS type subscription. The actual Terraform stuff, there's no additional cost. So I use VS Code and I use Terraform, and I can define my infrastructure, and it doesn't cost me anything. Okay. One of the really interesting things here as well that makes my life a lot easier is the way that Terraform handles the interdependency between resources that I'm defining. So if back when I used to start off with Azure, I was a big advocate and fan of using PowerShell rather than anything else. But I had to make sure that I defined my scripts and wrote my script in a particular order to make sure all of the dependencies lined up correctly. So I needed to make sure that I deployed the resource group, then I deployed the various different resources in the right order, otherwise my scripts would fail. And that took a lot of brain power. I'm inherently lazy, and therefore that's why I'm a huge fan of automation. Terraform I like because it will figure that out for me. I can define my infrastructure resources, and I can reference, so I can either have implicit or explicit dependencies. We'll look at those in a demo later, but essentially what it means is that Terraform knows which order to deploy things in. And what that means is when it comes to do the deployments, it will do them either in parallel or serial, depending on those relationships. So if I'm deploying 5 VMs, I can do that in parallel. There'll be various components within those VM deployments that need to be run serially, but it means that you can end up with a much faster deployment pipeline. You haven't got to handle all that parallelism yourself. It's all written into the platform for us. And the key thing here is about state management. So I want to be able to run and then rerun my my deployments. I want to be able to run a plan. And what it does, Terraform gives me is the ability to say, okay, well, what if? Okay, so I've got my existing state for the infrastructure I've deployed. If I bring my next one along and say, right, this is now what I want to deploy, I can run a plan, and it will actually give me that information back and say, well, I'm going to create these, I'm going to destroy these items, and I'm going to update these items. And it all comes back in textual format, so it becomes very, very easy for us to start planning. Okay, is this going to cause an outage? Do we need to take downtime to do this deployment? Can we do it online? Because it's all updates, that type of thing. So it's a very, very powerful tool. Now, when we think about how Terraform is constructed and the various different components that we have, the first thing that we need to understand is, aside from the Terraform application itself, is the providers. Now, these providers are essentially the interconnect between the Terraform platform and the target technology platform. So the Azure RM provider, for example, is the bit that sits between the Terraform executable, my definitions of what the infrastructure needs to look like, and actually deploying it onto Azure, because that's the bit that will talk to the APIs. Okay, same for AWS, same for Google, same for VMware, same for GitHub. There's many, many tens of different providers for various different technology platforms that you may be using. So you can go and have a look at them. Now, if there isn't one there for a technology you're using right now, it's all open source. So you can write your own. If you think something's missing, for example, from a provider, you can fork it and you can add that functionality yourself. It's all written in Go. So it's a relatively lightweight. I mean, obviously the learning curve there, if you don't know Go, something we need to learn. So it's not, I'm not going to use the term easy, but the learning curve is there, and it's maybe not as steep as something that's, say, written in C or C++. Okay. And once we've got the providers, we have the resources that we want to deploy. Now, the providers will essentially define the structure that we have for our resources. So in this instance, this is where if I want to deploy a resource group to Microsoft Azure, then what are the key values that I need to give it: location, name, tags, things like that. Like if I'm deploying an Azure SQL database, what do I need to deploy? So the server, the name of it, the location, all of those things there. If I'm deploying an AWS machine image, okay, what do I need to there? What parameters do I need to give it essentially to allow me to have that thing come out the other side? And those are the resources that we have. Now, obviously, that can be very prescriptive. If I've got a virtual machine, I may have to put 10, 15 different values in there. That's going to be an interesting one for us to look at. We'll figure out how we can do that a little bit more efficiently later on. Now, in addition to resources, we've got data sources. The job of data sources essentially is if I've got resources that are external to my project that I want to reference, I can reference them through a data source. Now, Terraform does give us the ability to do, as I said, state management, and you can reference another state file. But if the resources potentially were not deployed through Terraform, then what it means, you can essentially do a lookup against that technology platform to pull information in to allow you to reference that data. And those data sources are essentially a read-only version of some existing resources. So I can go and gather information about existing resource groups, existing virtual networks. So for example, if I'm running a hub and spoke architecture, I can go and look up the core sort of hub VNet, for example, and all the information that goes with that, so I can then plug into all the components that need to go into that. As I mentioned earlier, we've got resources where I need to define a lot of things. This is where variables come into their own. I can actually add, I can define variables, and then I can put them into all of the resources and such like that I'm using. So if I want to use a data source, I can define a variable with a name of the subscription and the resource group and things like that I want to look up. And then I can pass that in at runtime. I can set defaults. So again, this is where we start looking at taking that encapsulation concept and simplification. We can define all of this. We can put everything with variables, which means that all I need to do is then supply values for those variables. And I can either supply them in line at command line, or I can provide a variables file, which essentially has a map. It's a key value pair mapping for this is my variable name, this is the value I want to give it, and then I just pass that into the command line. And again, I'll show you that shortly. Outputs. Now, this essentially is a mechanism for saying, okay, I want you to actually output some information to the console screen. It's not a create file, for example. That's where you need to wrap it in something like, say, Bash to take the outputs that come to the console and direct them somewhere. If you're using Azure DevOps, again, there's an option to automate deployments. There are pipeline components there that will consume the output from the console and pipe that into something else that we need to do. But essentially, I can say, if I'm deploying some, for example, Azure SQL database or virtual machine images, things like that, and I want to get the name, or I want to get the IP address, I want to get the name or the configuration details for a particular endpoint. For example, if I'm going to SSH into something, I can have that come as an output after everything's run, output that to the screen, and then I've got that information. If I've got to output it into the pipeline, then I can store it somewhere. For example, put it into one of the like Azure Key Vault for secret management, that type of thing. Okay, so there's a lot that we can do there about taking information that's generated when we do the build and the deployment, and actually then do something with that output. But it doesn't create an output artifact or a file. It's more, it comes to the screen, and then we've got to do something from there ourselves. Now, again, this is where we're thinking about the complexity. We've got quite a lot of resources we may deploy as part of an infrastructure. Do we break that down? There's various different things. But what we can do is we can wrap it all up in a module. And a module in Terraform terms is essentially a folder structure. Okay, so there's a wealth of them available for free online in the Terraform GitHub repositories. But additionally, if you want to build your own, for example, you can define a subsection of your infrastructure, and you can modularize it, put it into the folders and nest it. And what that means is that you've got your own internal infrastructure component, which is something you just pull down off the shelf and plug it together with some other bits and pieces to give you your overall infrastructure. And again, you're encapsulating and masking a lot of that complexity that goes into deploying and defining a particular infrastructure. So it is as simple a case as defining all of your resources, the providers you need, things like that, putting it into a separate folder structure, and then referencing it in a particular way. We're not going to cover that today because that's a little bit more complex than an introduction. we have got a whole raft of demos that we're going to start looking at in a moment about building up and understanding how we connect and go through from there. And all of these components together, combined, give us the Terraform solution, the Terraform platform. And again, one of the things here is not like a Visual Studio solution and project where you've got different project types. It's essentially a collection of files, okay? And we'll talk through that when we jump into the file system in a moment. So with that, we'll go into our demo. So here I have Visual Studio Code. And I've got this set up so that it will talk to my Azure subscription. Now, there's a couple of ways when we start thinking about setting up our Terraform folder structure, if you will. Over here, you can see I've got, let's do that. Here, I've got the demos that we're going to go through today. Okay, and they're all just different folder structures. Okay, underneath the master one. So if we start thinking about the first demo, the first and most important thing we need to understand is how we're going to actually authenticate against what we're talking to. Okay. Now, what I've got here essentially is the most basic folder structure you're going to look at for a Terraform deployment. I've got the folder and I've got a main.tf. TF is the file extension of choice. So that denotes that essentially this is a Terraform file. So when I run Terraform, what it will do, I'll point it in a directory and I'll look for all the TF files. It will basically then merge all of those into its deployment and it will work out those dependencies that we spoke about earlier. Now, the main one is what's going to have our resource in it. And what we want to do is look at deploying a resource group. I'm going to call it this, and I'm going to deploy it to the UK South Azure region. So how do we do this? So this is where we've got a couple of different options. Now, from an interactive perspective, when I'm doing development, I can use the Azure CLI to authenticate. So if I go AZ login, let's just see. Yeah. Let's see if that's logged in yet. Yes, there we go. So I'm already logged in, which is great. Okay, so what that means is now that if I start running Terraform interactively, I am going to be able to connect to my subscription. Now, what does that mean? If we go to providers, so if I just rename this to TF a second. So now I'm defining my provider here. I'm going to say, right, I want to use the Azure RM provider. Okay. If I've got a specific version that I want to use, then this is what I'm going to reference. Now, one thing you can basically say, right, pull the latest version. I would recommend against that when you start looking at doing anything with production infrastructure, because you want that consistency. And as this is an open source, it's constantly evolving. New versions coming along may introduce something or introduce a breaking change, which you don't necessarily want to have to go back and work out when you've got that coming straight in. So what I would look to do is say, well, version 3 of my infrastructure uses this particular version of the providers that we're using here. Okay, and then I'm specifying which subscription I want it to do. So I've got 3 or 4 ones that are available to me. So if we come back to this and we see main.tf, if I right click and let's just open that in the terminal for a second, save me having to type anything. If I type in Terraform plan, what this should do is then go off and say, okay, well, what do I want to do? But before we can do that, we've actually got to initialize our directory, if you will. So Terraform init. And what this does is it goes off and it will just look and understand, okay, well, what providers do I need? I'm going to pull all that information down. And you'll notice that I now have a .terraform file, folder. And within that folder itself, I've got the provider information and the lock information, things like that. Okay. So now I'm in a position to go Terraform plan. And what this will do is it will go off, it will have a quick look at things for me and say, okay, I want to see, okay, what's existing at the moment versus what needs to be deployed. And we can see here that I want to create this set of resources. So I'm going to create a resource group. The ID is going to be known after it's applied. Now, the Terraform Apply command essentially allows us to say, right, make it happen. Okay, it's going to be in the UK South. That's what I'm passing in. The name is known because I'm passing that in. And again, tags, because I'm not passing in discrete value, it's going to say, okay, well, I'll know this after we've done this. Okay. Now, the other option, if we want to start looking at automation, is use things like either managed identities or service principals. Now, one thing we can do is we can create a service principal, for example. So here I'm just going to use the Azure CLI to create me a very basic service principal, which would be good. So what this means is that it will go and create one for me, and then it will spit out some information which is useful for me. Go. So essentially what I've done is create a service principal, said, right, it's a contributor on my subscription. Here's the password, tenant, and app ID. Okay, I'm going to just click down. That, because what we can do is, if we look at the providers too, this is where we can specify additional information. So I can say which subscription, which client, password, and the tenant. Now, ordinarily, I would put this in here for some development work. If I'm looking at deploying this via automation, I would not put those values into this file. Okay, if I'm going to commit this to source control, I would put placeholders in here and then use something like Azure DevOps or Jenkins to do token replacement. So I'd have a common token value here, and I would pull that information from a secret vault management system, so Azure Key Vault or Terraform Vault, or sorry, Hashicorp Vault or something like that, which means I can pull those secrets out of somewhere secure and I can basically put them in at runtime, and I haven't got to persist that information somewhere where other people may or may not get access to it as a privileged scenario. Okay, so if we come back to this one here, and if we go to this one here, and then we go Terraform Apply, much like when it does the plan, it will go and say, okay, what's there at the moment? What am I going to do? And what does that actually mean? How does that manifest itself? Okay, so I can say it's going to create these, and I can say yes. Now there is a command line value that I can put in here as well and say, just do it, don't bother asking for this, and that's something that you would look to do when you use an automation. So what that means is I've now deployed my resource group to Microsoft Azure. So where do we go from there? State management, this is an interesting one. We've got the Terraform state file. Don't ever modify this. It's essentially a JSON file that describes everything out there. You can see here we've got the ID value now for the subscription and the resource group itself. We can see all the information there. Now, that's all well and good, but that's on my machine. What if I'm working collaboratively in a team, that type of thing? This is where the ability to store state remotely comes in. And this is where you can use Amazon S3 buckets, you can use Terraform backend, or as I'm going to use here, you can actually create an Azure storage account, which will then hold our files. So if I do these a second, so I'm just going to run some commands in the Azure CLI. So I'm going to set the account I want to work in. I'm going to create the resource group I want to put this storage account into. And then I'm going to create a storage account. Helps if I don't highlight just one word. Okay, that's going to create me a storage account. And then what we're going to do is we're going to create a container within that storage account, which is going to hold our state files. So just give that a moment. Now, why would I use remote state versus local state? Remote state means that if I'm working in a collaborative environment, when I'm applying something, I can lock that state file, which prevents someone else from doing something. So again, if we're in one single environment, it makes life a little bit easier for us to do that. So here we go. Okay, right then. So we deployed our storage account. What it means is we need to come in and basically define the backend storage. There's also a couple of files we need to just drop into the file system, which I've already done, and there'll be more information in the slide decks that I'll publish for everyone about just all those pieces you need to do. But essentially what we're doing is saying, this is where we're going to store the information. This is the resource group storage account container name we want to do it. And this is what we're going to call the state file. So it's demo2. Okay, much like before, we've got a resource group that we're going to do, and there's our provider. So if I come down to here again, so come back to that one, come into there, initialize it, and here you can see it's initializing the back end for us. Okay, so it's created the bits and pieces it needs to, it's downloaded the various providers, and then if I go Terraform Apply, what this means it will do is get this to come through and say yes. Okay, so we're just going to deploy another resource group. This time it's going to have demo 2 in the name. So we're going to look at my Azure subscription in a moment. We'll see more of them coming in. So if I come back to my resource groups here, so there's demo 1, which we created earlier. Sometimes the portal can take a little while to come up to speed, but here's the back end one. Here's the storage account. If I come into the containers, we can see there's the Lightup, and then there's the Terraform state file. See all the information in there, and I can actually hit edit, and there we go. So that's our state file stored centrally for demo 2. So if I'm working again with my team, then I can take a lock on that if I need to prevent them from doing anything whilst I'm doing the development work. Again, also it means if I'm using multiple development machines, that type of thing, I'm in a much better position to really just sort of make sure I can make sure my productivity is as high as it's going to be. So let's see if demo 2 resource, yep, there it is. So demo 2 resource group has shown up, which is nice. So on to demo 3. Okay, so variables. So you've seen so far in these ones here, just close those down. If we look in the main, main.tf, you can see here that I have specified the name and location in the file itself. But that means that obviously if I want to change this, I've got to come in and change every file. This is where variables really come into their own. So there's providers, and you can see the syntax we're looking at here is I'm saying variable called Azure subscription ID, okay, is going to be there. So if I come to this one here, right, so within this one here, I define and declare my variable. I can define the type, I can set a description. I can even set a default value, okay? So the description, if you're doing it at the command line level, will basically prompt you. So try to put a descriptive thing in there about what it is that you're going to be asking for an input for. And then when I look at main.that, there's a couple of different options we have available to us now. This option here is referred to as the interpolation syntax and is deprecated. Moving forward, we should be looking at using the syntax here for location, but just for completeness, I thought I'd include both of them for you. So if we do this one, 3 into variables. Now, Terraform init, so we'll initialize everything. Okay, so if I go Terraform Apply, let's just do apply. Okay, it's now asking me for the values I want to put in. Now, this could be quite arduous if I've got a large, so if I just exit out of that, one of the options we got is then to use what's referred to as a TF-vars file. So this is a file which is actually going to contain the values we need for our variables. Okay, so if I do Terraform Apply, var file equals /vars. I'm trying to remember what I called it. Demo.tf-vars. Okay. What that'll do is it means I shouldn't get prompted for anything because the variable file will provide all of that information. He says. Okay. So there we go. It's gone and said, this is what we're going to do. You can see the interpolation syntax is deprecated. It's going to add all of this information in. You can see that yes, then that should go off and deploy our third resource group. Okay, there we go. So nice and easy. This way, I can pass all that information in. Now, when we're starting to use cloud resources, one of the key things that you want to look at is, at least in my experience with Azure, you want to set up tagging policies. So I want to tag resources so I've got more metadata around what they're for. So for example, I may want to put cost centers in there if I'm going to be rebuilding to other departments. Is it production? Is it development? Is it something that's going to be automatically cleaned up? So you can see here again, we're starting to really build out now the folder structure with more files for Terraform. So again, main, providers come down into tags. Now, I tend to break tags out into their own file just for ease of maintenance. But essentially what I can do here is I'm using a different type of variable called a locals, which allows me to build essentially these hash tables and such like. So common tags, and I can define them all here in one place. So environment, person to contact for it, a cost center, is it what we're using it for, and when was it created? This is, at least if you're going to use Microsoft Azure, this is a huge one to be looking at putting in as a tag, because create date is not actually a property you'll find on pretty much any resource that you create. So I tend to create a tag with that so I know when something was created. So if something magically appears, I've got some information. You can create policies that will refuse to allow resources to be deployed unless you do that. Now, what that means is when I look at main, where I've got my resource group deployed, I'm using this merge essentially. So I'm saying, right, merge all of the local.common tags together so that I can easily deploy them as a single line. Now, what this means is that if I subsequently then need to go and add another tag, we'll do that in a minute, I just need to update it in one place. So if I come down to here, cd demo 4 for tags, initialize. Okay. And then Terraform Apply, file equals that. Okay. Resource creation tag. So what are the dates? 2020 0714. So if I don't put it into the variable file, then I'm going to be prompted for it. Yes. One thing you'll notice here is you can see that the tags are all called out. There we go. So that's all created. So if I come out to my resource groups, let's see if we've got demo 4 there yet. Not quite. Okay, so whilst we're waiting for that one, if I come back to tags, for example, and then if I wanted to say conference equals, just put this one in hard code it, Lightup, for example, save that. If I then come back to here and run another Terraform Apply, 0714, what we'll see is, once it goes off and does the analysis for us, at what's there at the moment and what it needs to do. Okay, you can see here it's an update in place, and it wants to add conference tag. So if I've got something that's built up with 20, 30, 40 different resources, all of which are tagged, if by using this sort of construct for using the locals with essentially the hash table of the values and then using the merge, it means that I only need to go to one file and make that update, and I can make that update globally. So if I now come down to here, let's see if this is appeared yet. There it is. You'll notice all of the tags in here. Okay. If I then come back to my Terraform and say yes, that should now go and make the update for us. Okay, so that's been one changed. So we come back to here, refresh, take a couple of moments to come through. Come on, Andrew, wakey wakey. So, let's just let's see if the portal's going to pick it up yet. There we go, we've got the extra one on there, usage, environment, but there's the conference one, which we just added. So again, taking that infrastructure as code perspective, we put it all in one place, we reuse that as effectively as we can elsewhere, we're in a much, much stronger position. Okay. So, let's see, we are for time. Let's get into that. Okay, so we come down to demo 5 now. Ooh. What's going on here? Okay. Second, the keyboard seems to have stopped working. Okay. Right, I'm having a bit of an issue here with my keyboard, it would seem. It's better. Let's see. There we go. That's looking a bit better. There we go. Right, let's get dependencies going. This will be the last one I think we get done, given the time we've got. But essentially, this is where I can create multiple different various different resources here. You can see I'm going to create a resource group. I can create this Azure SQL Server, and then I'm going to add an Azure SQL database on top of that. And then if I come down to this one here, so demo 5 is dependencies. One thing you'll notice is that I'm creating and for a moment, the resource group name. I'm actually referencing in the firewall rule, for example. I'm actually referencing the resource group name for another resource, and that's where I start building up that dependency between them. Okay, so if I go Terraform init, just going to pull that information down for us. Now, this is one of the interesting things that we can do. If we go Terraform Graph, what it will do is actually pull out the digraph for us. And what this means is that I can essentially come in and say, okay, what does it look like? And I can feed that into something like Graph Viz, for example, or whatever. So if I apply now, so I can take that, I can apply it, and then that will generate a essentially a graph for me. Oh no, that's why. Let's just quickly do that. Var file equals vars vars. Okay. So what we should do is all goes to plan. You can see it's just spat out an awful lot of things that we need to create. All the various different bits and bobs. If I just go yes, that will now go off and create all of that for us. Okay. And you can see here it's creating the. I haven't updated the value. Anyway, moving on. Yeah. So as soon as we're running to time, just a quick level summary. Thing to understand is Terraform is a cross-platform tool, like I say. So depending on which environment you've got for your Linux, your Windows, your Unix, your Windows, it doesn't matter. The tool there for you, like I say, if you're running different build servers. If you want to use automation effectively with it, Terraform itself doesn't do automation. It facilitates automation. And this is where you want to use something like Ansible, Chef, Puppet, or whatever. But then also you can combine it with things like PowerShell, DSC, and also other elements of those technologies to actually control configuration inside those resources. So for example, if you're deploying Windows, Microsoft virtual machines, you're deploying VMware virtual machines, you're deploying Linux boxes, Windows boxes, things like that. That's where you can use PowerShell DSC or Ansible such like to actually you use Terraform to deploy them, and then you'll configure them internally using another technology. So this is all about resource management, not resource configuration. Automation, like I say, Azure DevOps, GitHub, Jenkins, Bamboo, any of those will work on your build servers. Just make sure you've got the appropriate hooks in there for the Terraform language. And if you've got Azure DevOps, for example, that has got a huge amount of built-in stuff that you can just pull into your pipelines and interact with Terraform. As I mentioned earlier, adopt those development focus sort of focuses for how we manage our code. Version your infrastructure, version your application code, deploy them together as units of work, deployment pipelines, and it just really makes our lives a lot easier when it comes to the governance, the management of infrastructure, and allowing us to deliver value very rapidly, but without having to do a lot of the work that takes a lot of time but doesn't realize much value. Okay, so deploying servers, it's great, but the value add is the work that you can do around deploying capability onto those systems, those applications you build, the database and systems performance tuning that you do, providing guidance and governance and everything back to the business. Those are your real value adds, performance tuning, stuff like that, not building and spitting servers out. Okay, that's why we've got infrastructure. And from there, have we got any questions? At all?
We don't have any questions in the Q&A forum, John. So for all the attendees, if you have any questions that you want to get clarified from John, this is the time to post it in the Q&A.
Yep, feel free, or if you think something afterwards, my Twitter is SQL Diplomat, so please feel free to reach out to me. Yeah, if there's nothing there, then I'll look to hand over to the next presenter so they can get ready and get ready to deliver their session.
Sure.
But I just want to say thanks once again for having me. Really appreciate it. And I'll quickly pop the QR codes back on there for feedback. So if you got feedback around my session, please feel free to provide that. And like I say, for the event coordinators would value that feedback as well. They're doing a great job, and it's good to know what they're doing well. So with that, I'll look to hand over.
Sure. Thanks, John. Thanks for the session, and thanks for the time.